Welcome to Chem Plus. Welcome to Chem Plus. Today we've decided to look at complete oxidation of ethanol. This is a very important A-level practical when you are studying alcohols. I usually call myself king of the classroom, but in this particular practical, in this particular lesson, I doubt I was the king of the classroom. Let's go. What we wanted to do was to oxidize ethanol through a process called reflux, and we wanted to form a carboxylic acid. We did form a carboxylic acid, but the class met with a few problems. Let's go. Complete oxidation of ethanol involves a process, a quick fit apparatus called the reflux process. The diagram I'm showing you here shows the quick fit apparatus used for reflux. At the bottom here, you've got your pear-shaped flask, and this is connected to a condenser. The condenser clearly shows water in at the bottom and water out at the top. We do not put a lid here. We do not put a lid there, otherwise the whole process will explode. Now, this process of reflux is constant boiling and condensing of the reaction mixture. This ensures the reaction goes to completion as full as possible without losing reactants. Let's go. Right, this is part of the method for the practical. I am not going to go through all the 8 points. Your potassium dichromate, the oxidizing agent, potassium dichromate, acidified potassium dichromate, and ethanol are in this pear-shaped flask, and we hold the condenser and the flask using joint clips. You will see the joint clips in the next slide. That they caused trouble as well. They were melting, but I will just go through the problems highlighted in yellow. On point 3, it says add a few anti-bumping granules. That's the one that I want to talk about first. Some students did not know the purpose of anti-bumping granules. We explained the purpose of anti-bumping granules, that they encourage smooth boiling. The boiling is not vigorous. They encourage smooth boiling. However, some students wanted to put more granules. 4 or 5 would be enough. The major problem that we met with this experiment was on point number 8 on the screen. It clearly says use a water bath or electric heater. We needed to pay attention. We took the option of using a bunsen burner controlling the gas flow, and that created. The purpose of this video is to help you avoid the mistakes that can happen when you carry out this experiment. Number 1, we did not expect a poor water in, water out in the lab. The water in, water out was not working. We put water, we opened water from the tap here, but it was not coming out on the other end. The pressure was very low. But I could say the major problem was excessive heating. We controlled heating by turning down the gas tap, controlling the flow of gas to reduce the heating. What we could have done was probably use a wire gauze, as shown in this experiment. The wire gauze spreads the heating, or alternatively hold the bunsen in your hands and you move it across the pear-shaped flask. If we had done that, we could have succeeded. The method, however, clearly said use a water bath or electric heater. Use a water bath or electric heater to avoid overheating. That could have helped. The joint clips that are used to hold the flask to the condenser melted due to overheating. That caused loads and loads of problems. And finally, the other problem was when students tried to remove the flask from the condenser. At the end of the experiment, they were stuck together, and it took one student from the other group who had mastered the art of removing these to warm it up and loosen it up. What they needed to do was lightly grease the quick fit joints. You apply grease on the quick fit joints, and the bits won't be difficult to pull apart. I thought this video could help someone, especially with the problem of overheating. A water bath, electric heater will solve the problem. Should you try this experiment in the future, believe you me, you will be fine. King of the classroom with a different cup, the Lion Cup, signing out.